Hello, my dear students. Welcome to my physics class. Our today's topic is diagnostic instrument ultrasonography. Let's start now. What is ultrasonography? Ultrasonography is a diagnostic medical procedure that uses a very high frequency sound, that is ultrasound, and its echo to capture the images of the internal organs and muscles of the body. That is, ultrasonography is an imaging technique in which a high frequency sound is used, that is ultrasound is used. Ultrasound or ultrasonic sound means the sound of frequency more than 20 kilohertz. That is, if the frequency of the sound is more than 20 kilohertz, then that sound is ultrasonic sound or ultrasound. And using ultrasonic sound, ultrasonography is done. The frequency of the sound lies between 1 to 10 megahertz. Here, a medical specialist is performing ultrasonography of the abdomen of a man. Here, ultrasonographic machine, screen, keyboard, and here two-dimensional ultrasonography image of a gastrointestinal tract, and here 3D image of fetus. Components of ultrasonography machine. Here ultrasonography machine, this part is display, and this is transducer. Transducer is used to produce high frequency sound wave, and it receives echo. And here parts, pulse controls, here keyboard, CPU, and storage device, and here printer. These are the components of ultrasonographic machine. This is transducer. It is a very important part of ultrasonography machine. This transducer produces high frequency sound, and this high frequency sound is reflected from the organ of the body, and these reflected echoes are received by this transducer. Now, ultrasonography imaging technique. Here transducer produce sound wave, that is a crystal called transducer is stimulated with electrical energy to produce high frequency ultrasonic sound wave. This wave is transformed into a narrow beam. Here sound wave is produced from the transducer, and here object. A part of this sound wave is reflected from this object, and this reflected wave is received by this transducer, and here distance between transducer and object. This is original wave, and these are reflected wave. So this is the mechanism of imaging technique. Here the transducer is touched upon the part of the body needs to be imaged. When the beam incident on a muscle or an interface of the blood of different densities, part of the beam is reflected back to the transducer as an echo. The reflected echoes are then transformed into an electrical signal and combined, and then a complete image is formed. Here from this transducer a sound wave is produced, and this sound wave is reflected from the fetus, and this reflected wave is received by this transducer. The uses of ultrasonography. The most important use of ultrasonography is in gynecology and obstetrics. With the help of ultrasonography, the size and position of fetus can be known. In obstetrics, it is fast, safe, and dependable technique. Uterine tumor and presence of other pelvic masses can also be detected using ultrasonography. Milestones, defects in the heart, and tumors can be detected with ultrasonography. When ultrasound is used for examination of the heart, then this test is called echocardiography. Here, when ultrasound is used for examination of the heart, then this test is called echocardiograph. Advantages of ultrasonography. Ultrasonography is painless and don't require needles, shots, or cuts. Patients are not exposed to ionizing radiation, so the procedure is safer than X-rays and CT scans. In fact, there are no non-harmful effects when it's used as directed. Ultrasound captures images of soft tissues that don't show up well on X-rays. Ultrasound are widely accessible and less expensive than other methods. Precaution of ultrasonography. During the process of ultrasonography, the transducer is continuously moved so that it cannot send the beam to a specific region for a long time.